Hi, I'm Chris from Airwindows, and we're doing another live stream. And it's a little bit late, but I'm still getting over what was bothering me a week or two ago, and I will do my best. And what we have today is straight up a plugin coding stream. So a couple of things I have in mind today. On top of which, or among which, is drinking the second cup of coffee that I've made for myself. And then we're going to do some cool stuff with a bit of luck. I'll see. So you might remember that on Tuesday, I was writing a program in Godot, which I think even involved me making the stream be tagged as the Godot engine stuff. And what did that do? Well, I've been running that overnight for the last couple of nights, the thing that I made. Here's my reverbs reference. Things like this is what went into clear coat. Note that it's another 4x4 matrix. This is what went into wooden box. Note that all the delays are much smaller. And we've got various things. Here's a bunch of stuff that hasn't quite come out yet, and it is all much larger. Like Cake Cavernous. This is a large hall that's a 6x6 matrix with a 3x3 early reflections built into it. And this is all very heavyweight stuff. It's all doable. It's kind of all waiting for me to do something with. But then we've got this. So I made a whole batch of new possible reverb algorithms. And there's a number of things I was thinking about. Among them, I could simply take the 4 out of these labels, but I'd have to do it in a rather careful way. I'd have to make it const int d4 equals const int d, because there's lots of 4s everywhere else in these numbers, and we can't be deleting those. But as you can see, I've produced a pretty large number of reverb impulses that ended up being kind of all sizes, ramping all the way up to over here where we have ones in the 3,000 range, which basically means some of the reverb times in here are exceptionally long. And I've also responded in the Godot the audio developer chat saying, oh, hey, I've done this, so I'm starting to develop this, and I'm working on the plugin that is the sort of proof of concept for what this will be as a Godot feature. And I'm calling the plugin Ultralight. Reason being, and the VST will be slightly different, but not very. Reason being that it is a end-to-end or dual mono or multi-channel audio unit where we have this little burst of delay times and things. I'm also thinking in terms of ways to do a cruder and more efficient downsampling so that it can function fully as a reverb like my other ones. Because what I've currently got doesn't make reference to sample rate at all. I had to make a special low sample rate version of my test audio to run it. Hey, frog in the well. Bits are behaving well enough. You'll find out, because we're going to be exploring this. And then there's a further thing that I might be able to get some traction on today, or perhaps not. this one doesn't ever run double precision, and there's a reason. A couple of reasons, really. One reason is it's going to go into a game engine, and the game engine probably runs floats for everything too. The other reason is I want to look into whether I can do SIMD processing on this. And that's going to involve me looking, Chad, you have no idea. I was talking about this with some of the Godot audio developers who are sort of inheriting the very first form of audio that ever went into Godot, written by somebody else. And so they're kind of doing their best, but we're not talking a group of people who are revolutionizing the world here. What they're doing is trying to have an audio framework for Godot that is Godot's own. And so they're getting people showing up to the meetings being like, hey, you should just use this. It's our proprietary library, and it does all of the things for you, and it has all the everything, and then we won't start charging you until later. Or maybe they won't even be saying this. We have people showing up, and they're often touting some kind of third-party library. And I don't know what the licensing of these libraries necessarily is. I do, however, know that Godot is not quick to build into the engine dependencies. So the watchword, and it's entirely correct for this to be the watchword, is, oh, hey, neat guys, what you should do is develop that as a GD extension. You should develop that as a plugin, and then people can load your plugin if they want to use that, and it's all good. And that's correct. But what I'm talking about is contributing to the engine. And in so doing, I'm kind of not necessarily pushing the extremes. I can probably come up with some things where I can use some of my techniques and they will work. In particular, I'm wondering whether I can use a double precision accumulator for the audio, whether that's a context where it would make sense, because we don't necessarily have to have all of our math doing this. But I mentioned SIMD. So there's a reason all of this stuff is being floats rather than doubles now, even though I primarily develop for the double precision bus of Reaper, or anybody else who has a double precision bus. And I think we can close that for the moment. And that's because I strongly believe that for audiophile and music making qualities, the threshold of where you'll eventually pick up some thinning out of the sound is probably around, 36-bit floating point or something. It's not far from what float is already. Thing is, you do get to do massive overkill. And so if you can do the processing on double precision, and like Apple Silicon Macs seem to be able to do the calculations at equal speed no matter what you do. So there's no penalty for running double precision on like M1, M2, M3, M4, M5, etc., etc. And similarly to how I am a big fan of 2496 audio, not because you hear that specifically, but because that encapsulates what you can actually hear without needing to get too close to the limitations of what you can actually hear. That's my choice. I don't feel like going the full Neil Young 192K thing. It's like, well, if you really are incredibly excited about extremely high frequency noises, then sure, fine. I don't really buy that it's absolutely necessary. And as far as the stuff like 1644 or 1648, you don't honestly have to go way past that for a storage or playback format, but being able to do processing is always nice. So here's the thing that we're looking at. This is a stripped down, tinified Airwindows reverb in mono. because the idea for the Godot reverb we're talking about is coming up with an object that can sit in the Godot world and work within the engine. And it'll be a little bit like some of the lighting things. Oh, you can. I use Bandcamp. I bet Bandcamp can. Whether people are set up to hear it, I bet there are people who are set up to hear it. Like, dude, my Motu 16A could do 192K if you wanted it to. It doesn't have to, but I'm pretty sure it defaults to. I think some of the, like your cheap little Focusrite Scarlets, it's not that difficult for things to attempt to do those crazy high sample rates. It's almost like table stakes at this point for making audio hardware. People will be like, oh, you can't do 192K. Well, you must be previous generation then. Weirdly enough, all of my listening is done over a Lavry, and the Lavry does 96. Lavry does not do 192. And I agree with Dan Lavry that 192 is overkill and unnecessary, and you can do all of your audio purposes without it. But yeah, there's a lot of places where you could play back you wouldn't be able to play it back also over like Bluetooth headphones, because those are downsampling everything in order to be able to send their audio. Like, you're lucky to be able to get 4824 to something like AirPods. And if you try to give overly high resolution stuff to AirPods, they start downsampling you to like mono 32K or whatever, something terrible like that. So when I say SIMD, what I'm talking about is stuff I can't do here. You might see I've got this hardness control in here, and we've defined some variables up here. And we've got a pre-delay, which is technically larger than I actually need, so this is a fine time for me to step that one back down. We'll make it 10 times as big as before. And I've got this thing going on that is selecting between these various algorithms. So this is a comb filter. It is a delay. That's what a comb filter is apply a delay. This is an all-pass filter. It happens to be one of the old school, like, original MIDI verb forms of the all-pass filter. Rather than using 0.618, it's using 0.5. That is in line with the intentions of ultralight. Ultralight being, the purpose being, this has to run as fast as humanly possible. Because the trick is, in a Godot game using this technology, it needs to be able to act like, say, Escape from Kharkov, where there's all these different spaces everywhere. And you can be like across the map and hear gunfire break out and know, oh, that's in the underground, because it was happening in a particular acoustic environment that you recognize. You need to be able to do that in Godot, cheaply, easily, quickly. And this is my best bet towards trying to get it to happen. So the all-pass is a very common thing in reverbs. I've been doing all of my stuff with just comb filters and profusion of reverb returns, but there are people who are super unhappy with even my most recent reverbs, because they hate stuff that doesn't have all passes in it. All passes gives you that sort of smeary quality like MV or Cloudco. And there are people who are just kind of addicted to that. They don't want to hear something that sounds like a clear crystalline echo. So what I've done is Ultralight has 8 stages of all pass, and you're just selecting between how this stuff gets used. with the same delay lines and everything. So you can either use it in all-pass form or you can use it in comb filter form, which is a simple delay. And there's a feature called hardness that goes from 0 to 8. And if hardness is 8, then nothing gets applied at all. But increasingly, you start using more and more of these, and they are the first two banks of 4 echoes in the householder matrix. So here's the first batch. Then we do the householder matrix stuff. One of the things that I need to look into, could possibly do that today also, depends, is a thing where I need to go and look up what that is. A conference matrix. So what a conference matrix is it's a particular 6x6 matrix. Namely, this. So you'll note that where a matrix usually works like they have different multipliers, and all of these are just the ways that stuff gets combined. So what you would do is have 6 delays going into 6 delays, going into 6 delays, going into 6 delays, and so on. And the output, so for every single, like say these are the first 6, this is the next one. Oh, look at that. It's all curvy and stuff. I wonder what's going on there. You know what? Not my problem. It's fine. I think that's because this is offset in that direction, but no matter, doesn't matter. When you're building the reverb matrix, you've got 6 delays and you need to fit some of each of them into the next one. So rather than this being some kind of thing over the entire matrix, this is the way that you arrange how you combine, say, the first 6 into the next 6. And the way it works is like what's coming out of the first 6 is like the horizontal ones. And then every successive one from the next 6 that you go into is one step along vertically. So the very first input, you take 0 of one of the outputs, and then 2, 3, 4, 5, 6 in phase. The second one that you're feeding gets the output of that first one that the first destination got none of. And then the second source gets 0. Third source gets sent through. Fourth, inverted. Fifth, inverted. Sixth, in phase. And so on. You calculate it out like this. It is a way of making a matrix similarly to what we do in the householder matrix. And I can only understand it like by ways of graphs and things like that. For instance, I made the 5x5 and the 6x6 work because I was able to see what a householder matrix graph looked like when it was made to work in that way. And you'll notice that the 4x4 matrix, the E, F, G, H, right, the next ones along, have some of each of the sources going into them. But in this case, it's first one gets A in phase, and then these other ones are all out of phase. Second one gets B in phase. The other 3 are out of phase. So if you were looking at what the matrix looked like, it would have the diagonal line going down the middle. And I can show you that again. The diagonal line for the 4x4 matrix, which isn't a conference matrix, this is a special one that's a conference matrix, is 1, 1, 1, 1, 1, 1, or 4 of them, 1, 1, 1, 1, down the diagonal, and then all the other ones around it are negative ones. And that's what a householder matrix that is a 4 by 4 is. It's just a way of combining these things and sort of flipping and inverting them and making them go together in such a way that you can feed them into each other infinitely and then feed them back in infinite regeneration, and you get a continually sustaining reverb where it just goes forever and nothing changes other than it turns into a reverby sound. So the conference matrix, I have a householder matrix for the 6x6 reverbs. I have not yet tried this conference matrix thing, which would be slightly easier to do because there's less math. It's just adding outputs or inverted outputs or not picking one of the outputs to send, which is weird and interesting, and maybe that means you don't have to do that delay. So you could, in theory, build the conference matrix. Could you? I don't think you could. No, you absolutely could not, and I'll tell you why. So this is me figuring this out on the fly, right? And going, does this mean you could have it be just a 5 by 5 matrix since some of the outputs of the delays are 0? Answer is absolutely not. This is the reason. The next bank takes the output of 5 of the previous ones and ignores one of them. And then the next one along takes the output of 5 of them and ignores one of them, but it's not the same one. Same for here. Takes the output of them, ignores one of them. And so what you end up getting is everything is still accounted for, but it seems to be done in such a way that you're either flipping phase or just passing the audio through. And again, remember, passing the audio through or doing multiplications by factors of 2 is a very clean operation, whereas if I have to multiply by, say, 3, that's going to get more into floating point math, and you do wind up with error that way. When you're adding stuff together and the multiplications are by 1 or negative 1, that is a very clean way of working with the floating point math. So it's the sort of thing that'll probably work out well. I got to find out. But it does need all of the 6 times 6, so 36 delay lines in there. But here's where stuff gets interesting with this one. This is, I did this yesterday. I prepared this like Julia Child to show the stream. This is all doing the same stuff. I'll play it for you in a moment. Then we have another matrix. I do wonder whether this is a candidate for SIMD. This might well be a candidate, because look, we have an array of variables, all of which have to do plus plus. SIMD means if you load the thing up into like 128-bit, which is I think normally how we go. Normally the way SIMD works is it's 128-bit registers typically. I suppose there could be larger. And back since like 1999, it's been made possible to like load a bank of 32-bit numbers into an SIMD 128-bit wide register and run the same math operation on all of them for one instruction rather than say 4. And so this is the primary reason, maybe it's the primary reason, that stuff like Surge XT synthesizer just runs all on floats inside. No interest in doing double precision there. Because on the one hand, they're like this doesn't sound any different and nobody can hear that, and so you never need to use double precision. Reaper's being foolish in doing that, so on and so forth. Presumably logic is also being foolish in summing with double precision math, which is something that they took to doing. There's a lot of people who took to doing that, but the real reason is if you are running a bunch of synthesizer buffers and you got polyphony, and you need to manage like 32 sustaining notes. If you can have everything built out of 32-bit variables so that you can process 4 notes at a time in the space that would take 1, that's a big win for polyphony. So it's a pretty strong argument. It's an argument for being able to do more synth layering. It's an argument for being able to get more voices without stuff crashing or going wrong. And it's worth doing, so I'm wondering whether I can get Ultralight doing something like that. And again, it's probably not going to be stuff like the ++ here, although I would if I could. I want to look into that. But it could be things like these simple assigns, these references into arrays. I honestly don't know what's available. Typically for SIMD, you get to do stuff like these combined operations. You can do a complicated data multiply divide. That's something that is pretty common. I could start using in my own stuff where relevant, where there's a single operation and you feed it with the number you're working on and the multiply and the divide, and then do it in one operation rather than separate operations. And if you can come up with stuff to do enough of that, you wind up getting real gains. And then we've got this, which I ended up using on the feedback path, and that is a new experiment. I've always tried to do this stuff on the individual delays, and I'm wondering whether that is something of a mistake, whether it's messing with the householder matrix. Turns out the output of the individual delays is also what gets summed together to produce the output of the reverb. And we're passing it through, but it's basically just another matrix operation again. And again, case 0, 1, 2, 3, and 4 for taking one after another of these feedback paths and doing a filtering on it. In this case, it is a simple filtering. I mentioned to the Godot people I was going to try to implement a filter to put on the end of it for just making everything dark. Another good possible candidate for doing some nice SIMD if I can figure out how to make it work. And of course, if the old, given that this was Intel processors back in like 1999, this machine's running an Intel processor. It probably has the SIMD operations built in. This is post PPC. And who's to say PPC didn't also have that available, but I'm not sure. I guess if I try to experiment with it, I'll find out real quick whether that's supported or not. And then we've got a high pass, which does not look like you would expect a high pass to look. And that's because it started acting funny in the form of a reverb. And it looks to me like what I've done is I've moved it so the low pass came first. And then didn't delete this part afterwards. So that's easily fixed. So all of this is really very small as far as a audio plugin, as far as the reverb is concerned. There's like next to nothing to this, and that's on purpose. Because what I'm trying to do is optimize it so that you could have maybe dozens of these running in a Godot game, all in different places. Like in a largish room, you might have 4 of them in different quadrants of the room, so that it would give you a complicated sound picture. And the outputs would be localized. They'd be where the object appeared, and they'd be picking up sound within whatever their range was. So it would be like light probes, in that you would have the reverb picking up any noise that was emanated within a particular region. Not absolutely everywhere, but within a particular region. Possibly weighted by how close the sound-making thing was to the center, perhaps not. There might be a bit of a taper, a feathered edge to getting into the region. There might not. I could see either way, honestly. And again, calculated out for the purposes of efficiency. And then you'd be running around in these spaces, and they would hear all sounds that were produced in their spaces, but not necessarily each other. Or a lot of the Godot stuff has things in sort of banks. So you could have them do a kind of bit mask for what they can hear or not hear, because like the bottom line is they shouldn't be able to hear themselves, or they would just feed back. And if 2 were in a zone where they could hear each other, that is just feedback with 1 extra step. So you could make an argument for none of these reverbs should ever be able to hear any of the others, and they should only ever be able to hear sounds within their region. And you kind of gather those together, feed them to the reverbs, and the reverbs just sit within the environment that you're in and are localized sound sources, such as Godot's engine is already designed to deal with. Meanwhile, here's Shuttle. And here's Ultralight Release. And while I'm working on this, let's hear it a tiny bit. Not with any of my current generated audio reverbs. This is basically a clone of what I started with. This is not one of the new algorithms. This is an old algorithm. But you can do this. So it's a reverb. It is a reverb made entirely out of floats. So to some extent, it's not Airwindowsized very much. But you can do infinite sustain. Full hardness is, and I'm going to need to come up with better names for some of these things, so that could also happen today. You're hearing it. Oh, it's hiding underneath me, so let's move it to where you can see it. So this is all comb filters, and then if I lower this, it increasingly starts using all pass filters in place of the comb filters. Still not doing anything unusual in terms of the arrangement. So that's a different sound. That does not sound the same. I feel like this sounds deeper to me, but there's also that metallic quality. Oh, the whole idea is we're going to make ambiences and things out of it. This isn't even one of the final form reverbs. This is just the data that I had currently sitting around. Like, let's have a look. So what was this one? I'm not even sure. It's these variables. It's just these variables. I don't know what this went to originally. I think it was probably verb tiny. This is probably the sound of one side of verb tiny. So it's not been optimized in any way. But we can start bringing in the all passes like this. And that gives, I'm thinking it's gonna have something to do with how bare the room is meant to be. Because you make it more all-passy and lower sustain, and we start sounding like a real environment. And then if we do more comb filtery and maybe a little more sustain, what you end up with is something that sounds like a empty warehouse or whatever, which is very legitimate for a game engine. You may well have that. And then we've got a low pass. This is going to be how hard the walls and furnishings are. Easier determined on a long sustain, you think? Huh. So if we do a long sustain, we can hear what low pass does much easier. So you're almost always going to want some of this. Having no low pass, and again, like I said, I'm going to need to come up with better names for this so that people who only know about game engines can interpret it and be able to know what to do. But yeah, no low passing, there's no filtering at all. It's just sustaining away. And this is in increments of 0 to 4. So that's one stage of low passing, 2 stages, 3 stages of low passing, and then you get to crank it all the way up for 4 stages. Now Chad said all passes sound like a room with less soft surfaces. If that's true, then I can switch over to the comb filter and it will sound more like soft surfaces. Let's find out if I feel the same way about it. I think a middle amount will usually work for people. So this is low passing. But it's not just that, because we also have a high pass, and that's kind of new. I haven't done these very much. In particular, I haven't done these on only the feedback paths, I think maybe ever. I've always tried to do these on the individual delays. If we do this, some of the lows goes away. More of it as more sustain builds up. And then a second stage. Note that we're still kind of hearing the kick drum rumbling, but it's losing a lot in terms of deep lows. And this is what you get when you have full high passing. So the reason the subtleness of it is the way that it is, like here, I can switch over to this. So full high passing, and then no high passing, turns into nothing but rumble. So this is the degree to which the bass eats up or gets through the walls. I toned it down. So this would be more of a rigid, solid-walled, like a bunker, like a cave. And then if it's more like a, I don't know, Quonset hut without much rigidity to the walls. Also, we can darken it a little bit just to make it more realistic, because a little bit of darkening is probably going to be realistic. No, Decay, no. And then as we switch over to the sort of Quonset hut type thing, and we do have a pre-delay. I have many questions as to how the pre-delay is going to work in Godot. Like, there's a whole set of questions around that. Because game engines do things like apply pitch shifts based on Doppler and so on that aren't useful in musical terms. And another concept that could play a role in something like that right here is a sweep. Notice how we can get very different sounds out of different use of all passes versus comb filters. This is all comb filter. And this is half all pass. And this is entirely filtered. Whereas this is no filters. So yeah. So there's a lot going on here, even without me generating new reverb matrices that are optimized for this purpose. I would kind of like to hear what some of my optimized ones do. Oh, okay. Well, we'll see you later, Chad. I'm going to be plugging away on this all afternoon and see what I can get out of it. And then we'll continue onwards next week or whatever. We'll see how far I've got with it. I'm quite interested in the SAMD concepts, although some of them, like my use of ints, I'm not sure there's operations for that. I don't know whether they're like float only or what is involved. For that matter, I'm very curious as to whether there are accessible data types that are even more finely packed than that. If I could specify this to be running on 16-bit floats, I would absolutely try it. I want to hear what that sounds like. So it's probably worth me experimenting. So here's where we're at. Here's our settings. So one of the things I was looking to do was figure out how to relabel some of this stuff. But I've also got more work to do, seeing as I need to shift all of these down a little bit more and add more controls so that I can have my final output filter. And that's because there is grounds for running an additional output filter just for darkening the full output of it for the purposes of doing a distance filter that can be used in Godot. Godot's 3D engine is using some form of filter, and I'm wondering whether I can do one that is either better sounding or more efficient to run or both or whatever. So that is most definitely something worth trying. Specifically, I feel like, especially if I can figure out how to do SIMD and be working with 32-bit things and do 4 of them at once, I bet I can come up with an averaging filter where the multiple data is each successive stage of averaging operation. And that means it might be more cumbersome to code. So I guess I'm going to leave this the way it is for now. Somewhere I've written down my thoughts on what these things could be named to help people understand them. Although bits of it I can do that, and wondering whether I want to start changing some of these things into ints. Some of them I know that I do. Wouldn't it be cute if I could do that with RT60 as well? So here's the thing. This is all, and I don't know why I'm spending so much effort talking this stuff out, but talking stuff out's useful in its own right. I mean, I'm doing a live stream, but mostly this is just me hanging out, and sometimes people will oh, thanks for doing the live streams. I put it on and take a nap because you're talking so soothingly, and that's completely cool, if that's of any use to anybody. But I'm noticing that this isn't one of those days where 50 people are lined up being like, oh, cool, do the thing. Instead, it's kind of me doing the thing, and I'm just sharing it. I suppose people could tune in and watch later if they wanted. And I need to keep focus on what I'm actually doing rather than just trying to be entertaining for a stream with a few people in it who I would dearly like to be entertaining, but you're not here to just hear me hang out and chatter, unless you are, in which case tell me and I'll do exactly that. But you're here and figuring out what I mean to be doing with all of this. So here's the first thing that I mentioned. I need another control. And I'm looking to maybe do a filtering control that would work in the game engine that's made up out of averaging filters, and the way that it applies might be kind of stepped, by which I mean you would move and then suddenly an additional layer of averaging would kick in, rather than smoothly fading between one and the other. But this is all in service of being able to make disgustingly efficient reverb engines to run in a game engine in great profusion, in a 3D space, not necessarily a stereo space. Like in stereo, you will have these things in stereo. But in, say, binaural, if Godot ends up doing spatializing and incorporating stuff like OTRF functions so that it's synthesizing the human ear and the shape and proportions of the human ear, you could have a 3D space where the reverb returns are getting binaural localization. So you'd be able to distinctly hear, oh, the echoing of that vast chamber behind me. Or here's a reverberating space that I hear off in the distance to my left, and then there's another smaller space in front of me, even without being able to see them. And you could move your head a little bit, or pivot your character is what that would technically be, and then be able to make your way through a space simply by hearing it. And that there could be cool things about that. I know people are already doing games that use stuff like that. It's just a question of which kinds of engines they're using. And I'd love to be able to do something that contributes to people's ability to use cool engines to do things with. So G is going to become dry wet. Really want to come up with better names. I really want to come up with better names for this stuff. And I want to build in my concept for how to define the spaces. Because what ideally I would like to do is design this in such a way that I can put out my Godot program for making these. And then anybody out there would be able to come up with presets for the built-in Godot spatialized reverb thing, generating their own reverb spaces, or perhaps just doing them by hand. Again, it's just a series of numbers. If I specify a series of numbers that goes 136, 52, 53, 1261, 209, 473, we don't even necessarily need to use this list a const int. Technically, I could just define an array and have all these separated by commas, or it wouldn't be an enum because an enum is just sequentially. But I could just spell out an array with that data in there. And the idea is the Godot engine needs to be able to have a way to select presets, but I also want people to be able to doctor those presets or make their own. And among the things to go into the presets needs to be this hardness, high pass, low pass stuff. Not so much distance, not so much pre-delay, because I feel like those things are going to be part of the game engine. But yeah, like I have my heart set on this working a certain way. And it would be similar to if you did this. Like that. Like the presets would have the list of numbers above, but then you'd also built in the dedicated things in the, because these settings are going to lend themselves to certain verbs. Like certain reverbs are going to be useless in some ways and then be ideal in other ways. I'll have stuff which is like, this is like a boardroom, except for it needs to have high pass and low pass set like this and that and the other thing. And it needs to have the all passes in a certain proportion. Maybe I should just call it all pass. Except I've got that backwards, don't I? Let's do all km. Technically, I could extend this outwards, but I'm still wondering whether I can do some of these things using SIMD instructions. Any little gain I can make on this matters. And then I'm still struggling with, so that's going to be an integer. Several of these will. Technically, so could pre-delay, but I don't really want that to be don't mind me, I'm just thinking about if I specified it as literally just integers, but then the actual amount of delay was that integer multiplied by itself, that would cover the range from very small pre-delays to quite large. Trouble is, there's no special reason to do it that way, and it makes it seem as if it would be part of the stuff built into the game, where it's going to be something that's handled within the game. I could do it anyway. For that matter, okay, so here is a thing. There's no reason RT60 can't also be an integer. Let's make everything freaking integers. And I tell you what's interesting about that is when we are defining things, we can also define variables like that. And that's one of the things that would get built into the reverb design. So by choosing to use an integer for that, I now have to come up with a way of making it work. And I'm probably going to want to do a 0 to 9 so that not that I have to, though, all these previous integers that are part of the setting. Okay, so I am mostly thinking in terms of how to pack this into like a string of digits that could be the preset. Because people are going to need to use these presets, and there has to be a way of punching it into the reverb, especially since you want customized special ones for every little purpose. I'm really going to need to make my Godot program do an audio preview of the stuff I'm working on. I don't currently have that yet. Seems like it would be good. Although, mind you, once this is actually a thing, I can just add it to the generator program, and then it can punch this stuff directly into it, and you can have the reverb immediately upon generating it. That would be pretty wild. Can't do that yet. I don't have the capability of coding that part of things. I do have the capability of coding this part of things. So the only part that has no bearing on the game engine one is dry wet, which I've now moved to parameter G. So this is going to be So I have a variety of options here. If I want to encode these numbers in some way that is clean and tidy, I could make them in hexadecimal or something. I'm working with them as ints. If all of these settings are so neatly granular that they are 1 decimal digit, then the tail end of this string of numbers could be like 5500 distance A. Well, that's not necessarily going to adjust quite that way. Let me fuss with something. Okay, so if my numbers go up to 38, that covers the size of that pre-delay. I can probably bump it, though. It was bigger than that before. Maybe I can find something that has a neat little square root. Oh, I know what I could do. If we do that, and then my other number is limited to 64, that fits neatly. Because the square root of 4096 is, in fact, 64. So we'll run with that for starters. And once I get it actually working, I'll play with it a little bit. This one becomes all/com. I'd like to work out the way that that applies to the sound. Wall density, reflectivity, distance is going to be the final filter on the end of everything. So I need to add another parameter. I'm going to chug through all of this stuff until I can start actually working creatively again. Though this is still basically useful. So there's these things. I need to look into whether I can define a smaller, and who's to say whether it's even efficient or not. I guess this is going to involve me going and looking in Chromium. So we're going to take a slight detour. Let's look for the combination of all things. This is probably a more recent version of C++ than my computer is using. I'm developing on a Snow Leopard machine. So this is really the big win for if I'm able to make everything run on a cruder form of floating point. I'm also very interested in what that would sound like. So that's worth checking out. Because it could make things crunchy in an interesting way. Let's just say that. We also don't know whether these are defined. So that's one of the things for me to experiment with. And this is basically the stuff I'll need to start working with if I expect to use this technique. I know who I can ask about this more, and also who I should not. By which I mean there's one person that I could ask for help who has told me, why don't you just ask AI for this? And that's not how I roll, so we're not going there. Unless I wind up running across stuff on the web, which is just spew. But the challenge with that is that stuff might simply not work, so there's that. Again, SIMD means single instruction, multiple data. This is an example of the most basic form of C++, and the parts of it that work. Interesting. So one of the things I see here is we got a situation where stuff like printline is printing an entire bank of things because it's a SIMD variable. And then the cosines and sines and things, I don't rightly know why it's returning only ones. But, so SIMD vec int a equals 1. And it just made everything be. I'm looking at the inputs and then the outputs, and I'm trying to work out how this stuff works. And then B, and I return I minus 2. Don't know where we start I, mind you. But the output of that one goes minus 2, minus 1, 0, 1. So somewhere in there, there is a plus 1 that happens. I don't know where it defines I to get starting at minus 2. Or maybe it's just doing these sequentially. Yeah, so SIMD vec int a equals 1 gives you 4 instances of the same thing. Then, if SIMD vec int b and the following things defines, well, it's, you got this empty brackets in there, which implies it's talking about which instance is being used. And I assume that means return the instance that you're in minus 2 or something like that. Let's continue. Auto C equals A plus B. Well, auto means use the same data type that you're being given. That I do know. So C equals A plus B. Well, A and B have been defined to be various kinds of SAMD values. So when you print line C, you're printing the same box of 4 characters. I guess it's typically a 128-bit wide thing. And so A plus B is the output of A plus the output of B, however they ended up coming up with the output of B. There's bound to be a way of defining, like maybe SIMD vec int A equals 1, 2, 3, 4, and that gives you the individual values. And then D equals my abs C. Where are we even defining my abs, though? Probably scrolled up here. Yep. And then the print line seems to be custom. Fine, fine, fine. And so my abs is calling this thing, which is some C++ isms that are a little beyond me. But it's taken in SIMD basic vec int A, is defining what the variable is, and it's returning each element based on whether it's larger or smaller than 0. And flipping the phase if it is not larger than 0. So AutoD my abs did successfully make that be an absolute value as single operation multiple data. Yay. Presumably this is also where you could do the multiple data on like a plus plus or something, or anything arbitrary like that. Feels a little bit like this is just abstractions that could as easily be done. It's like, what makes this different from just making functions for things? Well, technically what makes it different is you're supposed to be able to run it as one operation on the chip. It could fall through to being any number of operations as long as it gave you the results, but the point of doing it is to make it run faster. So auto E equals D times D, and there's E, and it is in fact D times D. That did not in fact require making a special little function. The multiply runs on multiple data by the same, it's int, so you could do presumably D++, and each one of those individual datas would jump up by 1. And overloaded math functions are defined in SIMD. So I'd be looking for how far back did all of this stuff go in terms of retro machines. And then we do have honestly, I think that is just I think they've picked math operations that give you one as an output. That or, no. So const expression SIMD vec double comma 16 rather than just int or something. Well, I don't know if there are processors that do 16 doubles. Also, it's showing them as ints. I guess because vec double comma 16x bracket int I return I means it is going to be an int. In which case I don't know where double comes from. Wasting my time a bit on this stuff. This doesn't feel functional to me. However, this might be, if I ignore that, actually I just went straight back to that, but I wouldn't mind finding out where I can use SIMD basic vec. But here's the thing. Floating point types, including the selected extended floating point types, for instance, float 16. Let's find out. And that said, I can do this, but it doesn't mean it'll work in the VST. Nor does it mean, well, I mean, if it works on this, it's probably going to work on any modern machine. Modern machines probably are including all of this stuff. What I'm wondering is whether they invented some of this earlier. And yeah, it was just a bit of a derail, but one of my questions is what happens? Can we do something like you know what? If it doesn't turn blue, it's probably not going to work. I can test that by trying to build this, see if it crashes. It crashed. So in namespace std, it doesn't name a type. What if, I don't know why T is on the end of it either, but that seems normal. That seems like what they do. What if we just try to do this? Nope, doesn't name a type. Also, there's other problems. That's not my first problem. We'll go back over to here. And look at what a half precision. These are very popular these days too, so maybe you call it half? I want to hear what this would sound like on audio. I want to hear whether it's crunchy or not. It should simply work, but I do not know whether that is even a thing. Okay, no .NET language has any of it. It seems unfortunate, but okay. C++ 23 did what I've currently got there, but unfortunately, that no works because I'm building on a snow leopard machine from back in the ages that no longer has this. Swift will do it. Doesn't matter to me, though. I feel like this is all very modern stuff, but specifying something to run on my old machine and also work on the So single can also be referred to as simply float. I'm looking to see whether there's anything in the language I'm using, which of course is here, that's a floating point format that both this old machine and newer machines would understand. I may be straight out of luck. There may be nothing I can do here. Yup. Well, I do have this. So this specification is strictly Apple. These purple letters mean I'm using something that's either Apple's code or is specifically Core Audio, or I'm not even sure. There might be special behavior to this. I do not know what it is or how to look it up or anything. Well, I might be able to find out how to look it up by inspecting this a little bit. I do have a jump to definition option. Let's see what it does with that. Haha. Cool beans. Okay. So we've got a series of type depths. Type depth float as float 32. So basically this is exactly the same as if I had said float. There's nothing gained from doing this. On the other hand, if I said float 80, that's the same. If I said float 96, I'd get this stuff. It's a struct. If I said float 32 point, that's a two-dimensional variable. It's a struct. So we got char and pointer handle and size. I've got type defs. So things like sint 16 and 32 are clearly available variable types, as is char. If I scooch up to here, see, this is the kind of thing where people have always dug through this to get their answers. I've never really been quite smart enough to do that. So we're going to see what I can do. Floating points, based floating point types. These are apparently my options. (32, 64, There's an 80-bit, which I think might have had to do with PowerPC. And there's a 96, which is apparently constructed by SN16, UN16. So that's a signed exponent, 4-sized mantissa, and then a whole bunch that's undefined. So that's 16 pad bits. That's super useless. It's the same as this 80-bit, but something else is wrong. Okay, 96-bit 68881. That's a processor. That's like a floating point unit for antique computers. Hey, Renato, I don't know if you can call it a privilege. If it is a privilege to see me grappling with this kind of stuff, all I can say is, like, rock on, have fun, because that's all I'm doing. Currently, I'm trying to find out if I can specify some form of low-bit float so that I can hear what it sounds like when working with it, just with the usual compiler. These are all fixed point numbers, so that's not as helpful. Seems like Apple's code is designed to work on a bunch of different compilers, which makes sense. And these are all integers. I don't want an integer, I want a weird float, but I'm not getting them. Okay, so from back in 1985, this stuff was going. I fear I'm stuck with this float 32 and float 64. All that means is float and double. When I replace this with float and double, it is exactly the same as if I had been using those from the beginning. And I don't see any access to 16-bit floats, and that makes me sad. But what do you want? That was being overly ambitious anyhow. Unless we have some kind of cool variable in here. Probably not. Yep. These type defs, you can declare something as byte pointer, but what you get is a uint8 pointer. You can define something as a const logical address, but what you get is a const void asterisk. And you can define something as an OS error, but what that really means is 16-bit int. And that's how this stuff works. Oh, look at that. We've got multiple type defs. You can declare something as an OS type, which is really a 4-char code, which is really a uint32. So a 32-bit int. So if you define a res type or an OS type, it's an int. It's a 32-bit int. And you can define something as a Boolean, but it's actually a char. Interesting. Although bool is an ISO C, C++ standard type. Yeah, I think we have run out of steam here. This isn't giving me, it's giving me ways of doing 16-bit ints. It's not giving me any way to access a 16-bit float. Because what I'm looking for is something that is overloaded so that I can do normal math operations on it and it will just work. There's more modern stuff that works with this, but this isn't one of them. Well, that's irritating. Look, you can define a Pascal object for 68K machines. Just about nobody's using those anymore. That was before PPC. I started out in one of those. Here's all the defines. More type defs. So yeah, technically, yeah, I get to use that kind of variable. It would even work. Oh, it wouldn't even work because there's no so that you cannot convert it to a float in assignment, and there's no match for operators like equals and plus for that kind of variable. So it let me do it, but it wouldn't have let me use it for anything. Hey, Aurora, derping around with stuff. Let's do a little of the things I can do. Been playing around enough with things I can't do. I love how it lets me declare all the different kinds of ints I could possibly imagine, but the floats, oh no. There's very limit to what you can do with floats. Seems deeply unfair, but there we are. Probably in a modern machine, I'd be able to define something like a half or something like that. And since it would be running a more recent version, it would be able to make sense of it. Unfortunately, on this older machine, on this Snow Leopard vintage Mac, you got float and double, and that's it. But we can make more controls. And then I can start coming up with a float-based stackable averaging thing, which is what I would like to do. I'd like to see whether I can do something like that. Got some changes to make in here. But we'll start with just this. And if we save that and build it, we've got some mistakes. Let me show you what these mistakes are. These aren't floats anymore. Everything from the very beginning all the way up to dry wet are in fact ints, with defaults based on them being ints. So all this stuff now has to change. Fortunately, I've worked with this before, so I know what to do. And then all of everything else has to change. And when I do a VST plugin, I have to port it all back to floats again, because VST doesn't let me define ints here. But I'll show you who does. See, it turned blue, meaning Core Audio knows what that is. And then we need to assign min value and max value to match what it's supposed to be. And all of them are now ints. Starting out at 0 to 10. So the other choices I have available are what's the maximum value for these various things. And that's going to relate to which thing I'm working with. I'm basically happy with the first value being 0 for all these, though. So let's go through and scan a little bit. Rather than cast these things, also, we've got a reversal. We've got a reversal. So in order to make stuff like high pass and low pass work, assuming that they are limited to 4, we got to do literally 4 minus per MC, 4 minus per MD. And hardness goes to 8. So let's say in regen is completely off the map at this point. But we can simplify it a whole bunch. Here's what it was originally meant to be. And you know what? We can multiply this thing by a float and it will be promoted to a float, so it can be the maximum values can be 10, 8, 4, 4, and then I'm going to need another one. What do I have first? Pre-delay or not? Distance, then pre-delay. We'll use the same names for things. We will update some of these names to match what I've written there. Reflect. Did I just... Let's make sure that we have it set to update all the things. All comb. All dense. Low pass. Becomes... distance, pre-delay, and then dry wet can be wet still. So, good that it's spelled differently because that's already a variable. Distance, not actually that anymore. We got to use F and G here. My hope is, in tinkering with this, I can make it actually work full stop. Like I'll tinker with all of these and then I'll run it again and it will actually work. It'll have integers where the floats used to be, and it will show me what the exact numbers I've gone to are. But the goal is for it to actually work. So let's see, first of all, if that was the maximum to add, we add another 0 and then go from 0 to 10, and that gives us a setting, a degree of settings in there. So regen we can follow the pattern. goes to 10. 5 is its middle. Alt comb goes to 8, so 4 would be its middle, so I can make that be the default. The density and reflect, we can have those default to 1, have them be engaged in some way. Distance won't do anything currently. I could have it go to 10 just on the grounds of, because here's the thing, like if I'm filling in integers this way with the intent of coming up with numbers that can then be passed through to the Godot version of this, and people can build them into their reverb designs, it doesn't necessarily have to just be a digit. It could be any integer number. I could have it be going from like 0 to 128 or 0 to 4096 for a lot of granularity, but I'm not going to want that kind of granularity. I want somewhat fewer options. And yeah, distance doesn't have anything to do with pre-delay. We'll ignore that. Distance just becomes param e, and I'll be figuring out what its maximum value is. I'm contemplating the idea of making all of these go from 0 to 9. Except for the ones that don't go to 9. Like again, the wall and the reflect 0 through 4 are valid. There is no further degree of that. Well, I mean, people aren't going to be using this. Game developers are going to be using this. Or me, literally, is going to be using this, and game developers will be picking presets that I make. And we've yet to hear any of the presets that I've already made. I'm in the process of building them. And I'm curious as to what they sound like, but I've been so bogged down on this stuff that I haven't been able to do a damn thing with any of it. So let's at least do some of the, so 64 was the max. So if pre-delay 64 is max, I'm going to throw little comments in, seeing as this is all non-standard. And then I'm going to go and change these. And then further change the ones that need to be further changed. Actually, look at that. I can do this. That goes from 0 to 8. These go from 0 to 4. That means we can engage as many as 4 high passes or as few as none of them. And then E becomes distance. I don't know whether it is 9 that I'm going to want, but I'm going to have plenty of opportunity to play with it. Currently it does nothing, so I can call this anything. And that covers everything, I believe. When I say that covers everything, I've still got more to do, but that level of labeling everything has been done. So, Alcom is this raw variable now. No casting to int necessary. On the other hand, RT60 needs to get cast to a float, but that's fine. Wall density goes from 0 to 4, but it's 1 minus that. But we're no longer having it be 0 to 1 and then multiplied by 4. So what we do instead is we go 4 minus this. Because it's ints now. And in theory, that should work just fine. Alrighty, let's see if it worked. Still not trying the new reverb algorithms. We're on a more basic thing where we're trying to see whether the machine itself works even slightly. Honestly, it probably works at least slightly. It's probably not going to give me pop-up menus, though. It should be giving me just sliders again. I could be wrong. We'll find out. We'll totally go and find out. Fire it up again. And here's how this particular thing handles having integers. It no longer knows to make of any of that. It's showing it as a floating point number, but you'll notice that we don't actually get to manipulate it in such a way to make it be a floating point number. And our medium settings. Oh, and look, when we have it set to this, it actually snaps to the new values. Every program's going to operate slightly different for all of these. Like there's going to be plenty where the slider doesn't honor it being an integer. So you move it wherever and it only shows you what the output integer would be. Sounds like this. Infinite sustain, except for it's not, is it? And you know why? Because there was a change that I needed to make in order to make it able to reproduce the previous one. Namely, rather than going from 0 to 9, it needs to go from 1 to 10. Because 10 times what I've got there gives me the previous perfectly sustaining setting. A little quick rebuild and then we should be good. The thing about that though is I don't think we're going to want to give people reverbs that are literally infinite sustain. I don't feel like that's going to help anybody. So we don't necessarily want to be able to specify that. But for testing purposes, now I can do this. And who's to say whether maybe there is a worth in doing that, because we get to filter the feedback. And because we can filter the feedback, we can use that sustain in interesting ways. Here's an infinite sustain in the highs. Actually, let's suppress it. So it gets a little rowdy still. It really doesn't like that infinite sustain very much when you're doing anything with it. Or we can take the high pass out. Now we have infinite sustain on only lower frequencies. And this is the next most sustained available sound. And then if we're not filtering, our most sustained reverb does really kind of last quite a bit. Bearing in mind that we're also going to be using larger spaces for big sustaining things like this. Also, just for fun, what's our range of pre-delay? How does that behave? Oh, it dies. Okay, so that wasn't great. Oh, I know why. I know why. So note what's happening. I can tell you exactly why it did that and what I can do to stop. See where this says pre-delay times param f times param f? Pre-delay is the maximum size of that buffer. So if I had it set to 0, that was fine. But I've designed the size of param f to go from 0 to 64 specifically so if we just multiply it by itself, it goes up to the limit of what pre-delay is without going over. The previous one was a variation on pre-delay times a floating point number that went between 0 and 1. In other words, it was always smaller than pre-delay. This needs to do the following. Because rather than it automatically adapting to what I tell pre-delay to be, I have to set it manually now to get what pre-delay would be. So let's hit save and build it again. That is absolutely what went wrong. And now we can get to experiment a little bit with what the new pre-delay action acts like. I would also like to put in a really no, don't recover, you're fine. I'd like to put in a really primitive sample rate management, but not the current audio mixing style ones. So what do we got? We got this. So we'll call that a crappy little room. Here's the dry signal. So this is what the new pre-delay does. You got about 1/4 of a second of delay. And it makes some cracklies That doesn't worry me that much. I don't feel this is going to be part of the Godot part. And the range of adjustment here feels pretty good for plugin based on plugin based on integer values that aren't going to be carried over to the Godot version. That's technically what that meant. So no pre-delay, bunch of pre-delay. That seems basically functional. It's reasonably functional. Could make it bigger. Got a bit of an obnoxious sound. So, do we have this setting returning? Yes, we do. Time to see what the new ones are like. So I mentioned making it be a very long delay. Let's declare it as this, which is an unreasonably long delay and may be entirely useless, but this is one of the examples that I would want to experiment with. The way this system works, all I have to do is paste that in here. We'll make sure to not paste over pre-delay. If I build it, now it is setting all of those arrays to their new sizes, many of which are quite tiny, honestly. And we get the raw version of what I've been building this entire time. Like what you just heard was one side of verb tiny. And verb tiny is selected among billions and billions of different variations, some of which computers went through to find whether they were any good or not, and many of which I personally went and listened to see whether they were any good or not. But this is the raw output that may 100% be useless and horrible, or maybe it'll sound cool, but I won't know what it sounds like until I hit play. And that's like a supposedly giant stadium-y kind of thing. Well, if it's a giant stadium-y kind of thing, presumably it sustains really long. It does kind of collect into a large sounding space, and it's very efficiently done. So one of the problems with making a large sounding space is if you have really long delays, you kind of need the sustain to become darker. If you don't, you end up having these very bright noises. To make a patch for a Godot reverb where this sounded realistic, you'd probably have reflect way up, making stuff go darker, which is counterintuitive, so maybe I need to reverse that. wall density, likewise, when I turn it all the way up, the wall density goes to thin. And in fact, we can do the RT60 at full crank if we have full filtering. But with wall density at 0, there's no high passing anymore. So we're going to get a real buildup of energy. That we can cool off by turning RT60 back down. So what this means is that wall dense and reflect actually need to be reversed, which is easily done. I got that backwards somehow. Don't know quite how. Oh, don't want to go there. Not yet. So here's where we get them their variables. And in fact, we do want them to be just the raw variable passing through, rather than inverting them. Because that way we turn reflect down to 0, and it'll make it more like maximum. Well, let's run that again. Let's see if it seems to make sense if we run it again. The way I'm setting this up, it needs to make sense to people who are not using audio things. Although I could build everything into the presets. This could be just a tool for setting up the presets and determining what you give Godot. And then you select the things by name from a long list of patches and see whether you like them or not. Thing is, in theory, you could let people have options for how to manipulate these. Okay, so here's wall density 0, reflection 0. Distance also 0, but we haven't done that one yet. Let's make the walls be more dense and also more reflective. That's clearly very reflective, although it has nothing to do. Oh no, it freaked out. Oh, that's because we've just hit a giant thumb. Cool. I forgot to select an area and have it loop, so basically it just made a giant thump because that was in the underlying audio. I'm of two minds regarding how to make RT60 work. I kind of like the idea of having these things be a single digit. Then the settings for it could be just like, okay, 8844 done. And it's also time for me to do distance. Distance is going to be just more averaging stuff, but on the output rather than the feedback. Because it's a little sensitive on the feedback. Like when I say sensitive on the feedback, here's what I mean. We can get this rolling. So we got maximum wall density, maximum reflectivity, meaning we're not doing any of our filters at this stage. But if I kick in even 1, it'll end up darkening a little bit. Full reflectivity, unrealistic, so all this stuff is going to kick in faster for smaller reverb impulses. This is the largest one I could find, which is not honestly a very good one, but that's why I go through large numbers of these and throw out all the ones that are terrible. Also, wall density might serve a purpose for exteriors to make a sense of size. And then if we continue to reduce reflectivity, we get spaces that could conceivably be used as some sort of exterior. As in an outdoor space, which also means we probably cut our C60 down some more too. And then the idea is you would have lots of these in various directions. If you had an exterior, you would probably have some of these dotted around the exterior in such a way that there's always one on every side of you. So no matter which way you turn, there's some deep echoey reverberation in your space somewhere. But then distance is also going to play a role. And then supposing you're doing this, you're doing exterior spaces, but you're in a city or something. So granted, this sounds much more city-like than just open space. That's going to be partly a factor of what reverb impulse you use. And if we want it to be a little more reflective, we can get kind of into that cyber city zone where it's like exterior cityscape. So more reflectivity, so more like this. Or even full reflectivity. And this becomes sort of like one element of a larger cityscape where there'd be lots of these. It would just be a better reverb impulse because this is not of the best. Or you could have a much smaller RT60. And this is basically all it is. It's not literally a zero feedback, but neither is it that infinite feedback. Yeah. So what this is, Grins, is my attempt to start developing a reverb for the Godot engine. One that is purely mono and mono alone, and exists as a lot of different spots in a 3D space that just generate sound based on the non-reverb sounds within their sphere of influence. I think that will probably work nicely. So that's a decent start. What I would like to do now is do something with distance. So let's see where I have left off with that. And I believe I can quit out of here. We'll try some more reasonable settings soon. The giant settings, I'm going to have to generate more of those because many of them are going to be useless. But the point of me regenerating these rather than trying to reuse ones I've already generated for like verbtiny or clearcode or whatever, is knowing that it is a mono reverb. I get to do my evaluation using Into the Matrix, the Godot program, reasonably better, somewhat better. I'm going to continue like leaning in that direction, hopefully. And I'm gonna get off the stream at a reasonable time and go and make tacos rather than getting caught up in this and going super late. The idea with this is it will be a plugin available, but it's also doing a bunch of different things that aren't done usually when I make these. Earlier, I was looking into this and seeing whether I could do a half precision floating point. You'll note these are all floats. I don't code with floats, I code with doubles because the Reaper DAW is able to run a fully double precision bus. So all of my stuff runs doubles except this, because this is doing all floats specifically because it's the echo of a game engine, which its audio bus almost certainly is not running doubles. And since it's a game engine, it's looking to do things that are extremely efficient. And the question is, can I make a reverb which, even if it maybe doesn't sound completely awesome, you can have so many of them in the game space running incredibly efficiently that it still ends up being an immersive, awesome sounding experience. And that's interesting enough for me to do that I'm designing an entire reverb around floats, which normally is where I would be wanting to do doubles just for the purpose. And technically, there's stuff in here that I could do. Like, see, I'm doing a double input sample. So we're feeding all of these floats together. In hopes of being able to do SIMD processing. I could dig into that a little more. This might be a case, well, actually, no, I'm not sure it would be. It's more likely that you could do them in 2 batches. Or not even, because they're all individual, aren't they? But these pluses and subtracts could conceivably be SIMD operations, rather than simply having to do them all one at a time. Not that they're hard. They're not hard to do. And then there's an if statement stopping me from doing this overall. But then we've got the matrix operations, and then we've got stuff like this. Nothing stopping me from doing an SIMD++. Don't know about this stuff. That might not be able to do an SIMD complicated if. Don't know whether I can do a SIMD complicated array read wrap statement. I would have to do a this kind of thing, which looks the same operation, different data. So if I could code that, which is basically CI minus logic statement, additional variable coming in, option between subtracting end result, also with a plus in there, or 0. So it's CI minus D4I plus 1, or perhaps just minus 0. That's effectively an if statement based on CI is larger than the wraparound. If I could make that be an SIMD statement, it would be cool. Because that very much is the same little formula, the same little mathematics, the same little everything, just on different data, on different variables, on different stuff. I got nummular eczema. Oh, I'm sorry to hear about that. Yeah, like washing with soap can dry you out pretty good, yeah. But yay on not getting stuck with an unpleasant itch. That's cool. So yeah, I guess one of the things I must ask is, how do I formulate an SIMD plus? That's a very small gain, but it would at least be a gain. Feels like none of the rest of the stuff I get to SIMD at all. And that's annoying. But here's where I would be putting my output filter. So an averaging filter is composed of two elements. One is the last sample is the previous go-through as a sample. The other is we'll take that and add it to the current sample and divide by 2. We're averaging two samples evenly. If we stack those up, they start affecting things more. I feel like I should be able to do an array to make that happen. And iterate through the array, and then maybe iterate separately based on, like, the idea for this would be make it so that you can update it rapidly. You should be able to snap from one setting to another setting and still have useful data in there. There's a parameter I have in here called distance, which I'm not currently using for anything. And I can have that be the number of instances of the averaging and just burn through a succession of really primitive averaging statements, probably in a loop. I can go through the loop and go only up to the setting of distance to do only that many of the averaging statements. Each one gets the output of the previous one, otherwise they won't stack properly. And then when I have so I'm going to want to write a something. Or multiple somethings. It's not going to be about the pre-delay. Honestly, I can move this up to here because the pre-delay happens before the reverb. And then here's the reverb's stuff. And then we can put this distance bit over here. It's not going to have anything to do with these delay values either. It's going to go up to the largest possible setting for distance. Let's go and check that now. Further. Okay. Currently largest possible setting for distance is 9. I'm not sure if I'm thrilled with that. I feel like I should go harder. Let's see what it sounds like when you... I know that this computer can stack 64 of these really simple things on top of each other. So we're not currently using this number. So let's make it go from 0 to 64. And let's try to make something happen based on 64-bit, or not bit, 64 instance arrays. None of my arrays are called D. That said, I'm going to want more than that. I've got the input value coming in. That produces the output value going out. And then the preserved value, that is the average value, and that's what we're keeping. Let's just make this complicated. We'll stack it up like this, and then we'll simplify it once we have it making some kind of sense, if it ever does. I'm wondering if I can do it as simply as with one array, or if I need to do two of some kind. And I don't know what the answer is. But what the hey. If we knew what the answers were of things, then life would be much more easy. Let's continue moving this stuff around to be in the places I expect to find them. There, pre-delay, then the echoes and reverbs, then this new thing. Let's also bump that up a little. Technically, what I'm doing is adding like 5 extra empty things on the end, which shouldn't actually be necessary. I just leave extra space for some of these arrays because they've bitten me before, because I'm dumb and don't know what I'm doing. Prev sample. And that is going to be a float, so we're assigning it to a float. So this is so far still good. And then our maximum number to count up to is actually going to be 64. So in theory, this is real. So the concern here there are several concerns, really. There are so many concerns. We're just full of concerns. Here's a for loop. Here's what we'd be doing with the for loop. Whoa. We're doing long-winded explanations of things. We're also doing things one thing at a time. did I just call that? Don't mind me. I'm stupid. I don't know what I'm doing. And here's where we put our counter in. There. Now, if we do that, it's just going to crank and go. That said, that's going to do a giant, massive, so. Okay, so here's what I'm struggling with. That's going to do a 64 stage averaging filter. It's going to be dark, dark, dark. There's going to be no highs left. Oh, what camera do I use? Blackmagic Pocket Cinema. That's what I'm using right now. It's just Blackmagic Pocket Cinema 4Ks. Not even 6K. Sometimes you can get a hold of those for under $1,000. It is probably a couple of generations behind by now, but it's perfectly serviceable. So, yeah, I mean, by all means, ask me questions about the videos. Probably smarter about that than about this, but let's continue to try to be smart about this. So, we can set this to x equals 0, x less than distance, and then it will do variable amounts of this. There's a problem, and the problem is as follows. That's going to store stuff inside the memories, so that if you make it be very close up and there's very few stages of filtering, it's all well and good. But then as soon as you snap back to having filtering again, there's big pops and bursts of noise coming out, even in silence, and that's no good. Experience is subjective. One of the things that I have learned over the years is the times when I'm like, I'm stupid and have no idea what I'm doing, are the times that I need to continue attempting to do the thing, because my sensitivity to what I need to produce is clearly above what I'm able to think at the given moment. And it's really just a sign of dissatisfaction. It's really just a sign of being frustrated and wanting more cool things to happen. Almost by definition, than I'm able to make happen at any given moment. That frustration can be useful. That lets me do new things rather than just sitting back and being like, oh, I did this, it's probably going to be fine. So that degree of frustration is what has given you all of the Airwindows plugins over time. If there's a difference, it's that I've learned to appreciate that, although I'm sorry if it makes you sad seeing me go through it. But I've learned to appreciate that rather than just taking it at face value. I've learned to look out for those moments where it's like, oh man, the coding is driving me crazy today. Those are usually the times that end up useful. Here's an example. We could put all of this in an if statement. X now we have another set of brackets. Now all of this is only being applied if X is less than distance. Otherwise, it will just iterate through the rest of those like lightning. But guess what? If we're no longer using those ones, we get to do one extra thing. Else we get to blank it out when we're not using it. Now, maybe we don't want all 64 of these, but now what we've done is only applied it where needed, and then when we're not actually applying it, we're not touching input sample. It's only happening inside that if statement that input sample even gets updated. But we're blanking out all a prev sample rather than leaving it there with values sitting in it, ready to make popping noises when we move it back. And this isn't necessarily going to be great, but it's probably oh, hello. Why did that not work? What did I really call it? That's what we called it. Distance. Easily solved. The number of characters you can put into a VST, even though maybe we won't even be able to do a VST of this. I lie, of course we're going to be able to do a VST of this. That's almost a given that it's a plugin and all. Let's try again. This time we should be good. Meaning we're still on that giant verb, mind you. And we still haven't done the filtering thing I wanted either. Or rather, the sample rate thing I wanted either. But I bet this does something, might even be good. Distance is at 0. Let's keep full reflectivity up. Let's go for a very deep sustain. And let's go full reverb. In theory, if this is a long distant thing, you should be able to go far away from it. I'm a little concerned that I'm hearing zipper noise, but that might be okay in Game Engine because you would be not moving that quickly. And hear what it does when we snap it. And let's 100% just drum noise. Also, we're not filtering it at all. So as we move farther away from it, we get individual little steps. And this is what large numbers of averaging filters do. I don't love that I plainly hear clicking. Makes me wonder whether there's anything I can do about that. Like, what would it... It's storing outputs in a filter. I don't know what it would mean if I was to just attenuate what's stuck inside the filter rather than cutting it off, because what's happening is we have our full sound, we have our very filtered sound, but then if I move it from filtered to more filtered, we're introducing new average things which then do not have a value to them. And so those clicks that we hear, those clicks are things being set to 0. Because our averaging stops being like the full weight of everything going. And it sounds pretty fine as far as being a distant sound. Especially since the raw sound up close is this. Compared to that, this ain't bad. So the reason it's making clicking noises when I sweep it up like this is that every step that gets an increasing number, the saved up version is in fact 0. There might be a solution to this. It's not going to be there. And we might not need to do an additional array. So here's our little calculation. And the reason we're doing that is because if we weren't updating those previous samples, then there wouldn't be anything in them. I can probably show you what would happen if we didn't have this blanky bit in here. Now it's out. So when we are not setting stuff to 0, what's going to happen is there will be a zipper noise still, but it's going to act kind of crazy. A possible answer would be to have a special case for what previous distance was. And if we are expanding, what we'll do is fill in prev sample with the current value. So it would kind of not be filtering right away, and it would soon start filtering. And that would also mean we don't necessarily go to the full 64 all the time. But yeah, I was going to show you what this did without the 0. It's good that we have this giant one to clearly hear what that stuff does. Back to here. There's our dark sound again. If we move it closer, no bad things will happen. But then if we move it here, at a point when it is quieting down, there's that clickiness happening. So I can demonstrate that as follows. This is an even more obvious crackling. And that's because there can be energy in here. Especially if I set it up like this. the zipper noise is quite obvious. So that's because I took out those zeros. And yeah, decay, this is one of possibly thousands of reverb possibilities that will be part of this system. I don't have an ability to make the plugin handle the custom settings quite the same way. So let's see. Looks like I'm going to be using a pref distance. Going to have to do a pref distance. Not only that, since it's pref distance, it has to be defined in the H file. It persists. There we are. And we're replacing something in the middle of our code rather than the part that's being changed. So we do need to set this. It's an int, so 0 is acceptable. Then we've got distance here, just being taken raw from the 64. It would be quite fun if I could do a SIMD here, but I probably cannot. I also do wonder whether I can get anything interesting out of skipping this preserve original stuff, because it would run faster if there was a degree of feedback in there and I wasn't worried about having pref sample not be an already averaged value. And there's possibilities to that. Among others, it would make things darker. That's not necessarily bad. Let's see. So we're going to do that's legitimate. There's going to be more in here, and then it will end. So if I'm not mistaken, I may be mistaken. We're looking at being able to reset the stuff beyond where we're currently at. And we're going to eventually want to do x less than distance. We're going to only want to iterate as many as we need. Remembering, of course, I've changed the name of it to this. And then I think we can reset it every time through. Kind of like after the entire statement I might be completely wrong, but we'll see. Okay, so in theory, we just done something that will at least run. Might not be good. It should at least run. And I don't believe it's doing anything I want yet, but I want to see whether it at least runs. Always the question, right? Question is, the things that I did it just make everything blow up and die? One hopes not, but we'll find out. Okay, it runs. This is the original sound without any filtering. Here's the very distant sound with 64 stages of averaging, which I think is quite a good way of making stuff sound real far away. So if you were like literally right inside, it would be like this. If you were across the room, maybe like that. If you were down the hall in another room entirely, maybe more like that, and so on and so forth. But what we're trying to do is not have this dumb clicking. So is there a way I can attend to that? Well, I will notice that now we are only counting the, okay, so if we lose that entirely, what happens is if we never update prev distance, then it will never apply any filtering at all. Let's demonstrate that concept. So in this case, if it works, it will become completely ineffective. Bingo. So we're applying the result, but it's only actually able to fill in these bits of data at the point that prev distance is doing anything. Once we put this in, it's going to start incorporating everything. But up to that point, we're going to get that crackle. So the thing to do to not get the crackle is to not throw in zero values unreasonably. How do we go about doing that? By making all the previous samples equal the current sample is basically how to do that. So then when we swoop it in this direction, rather than being filled in with sudden additions of 0 to be averaged against, it gets filled in with sudden additions of whatever the current sample is at. Remember, we're doing one sample at a time, but this is a big filter, and it's an averaging filter. we are going to do another for statement. But now, brief distance isn't necessarily distance. But we'll start from there. We're still going to check that it's less than distance. But if brief distance was already larger than that, then it's not going to, should still work. And then brief sample x gets to be equal to something. But guess what? It gets to be something different this time. All of these just get assigned to input sample at this stage. So as the averaging kicks in, it kicks in from a position of this was already exactly the same as before. So therefore there should be no clicks or pops. If it works, which it might. And one nice thing about it is that it is a very efficient little for loop. Because we're just zooping on to the end result. And where we previously only applied the stuff that was in use, now we're filling everything else in with just input sample and not doing anything further to it. And then we set brief distance to distance, at which point we should be good. That should clean up the clicks. Let's find out if it's true. If it's true, then we can see whether we can make the whole process just a tiny little bit more efficient by losing this preserve original thing at the cost of no longer doing a really accurate averaging. But we don't necessarily care about doing an accurate averaging. We care about, does it sound cool? Might sound even cooler. So now we find out, does this work? Clean as a whistle. Got there. Lovely. Well, I say that, but I feel like I heard clicking as it was sweeping up. Remembering, of course, that's part of the audio. I'm still a little unsettled by the way that I heard some clicks as I was making distance smaller. I'm not sure that's a major problem, though. Bear in mind, when used for the purpose of game engine, I'm talking about distance being assigned to the distance between game elements and other game elements, like the distance between player and a sound-producing object. So rather than simply running a filter, we get to run this simple little chunk stuff that only goes as high as it needs to. You can do as many as like 64 or arguably more. I could add so many of those that it's not even funny, and it would be a little inefficient. But when you're not running a large number, you've just got an array hanging around not being accessed. honestly, I think this could work. Might even be a good replacement. Maybe I should code a dedicated plugin just to show folks what this was about. Because that's the thing, is Godot needs that kind of code. Godot needs a filter for audio distance attenuation. I have so many more complicated distance attenuators that I'm a little bit delighted that this particular one ended up behaving so nicely. I'm tempted to do one where I change this to a float and then make that number be a power function so that I can have a little easier time observing what the close-up stuff acts like. But yeah, the gist of it Okay, so let's pretend this is some kind of horrible machine. In fact, I'm going to tighten it up even more. Okay. That is technically a hi-hat, but we're pretending it's a machine in a space now. We're sitting here being annoyed by some grinding machine off in the corner. Now let's see what happens when we walk away from it and add more distance, bit by bit. So zero distance, we're like literally right on top of it. And this would also apply to raw sounds, because if this works, it could be used in Godot as part of the spatialization engine. So let's see what we get. A little farther. So the unit's clearly not feet. And then far away is what we get. So the secret there is that all of the individual sounds being created and thrown into mix, if most of them would require more processing cycles to do a quote-unquote proper EQ to deliver a similar kind of effect, then this, with an average distribution of objects in the space for however far away things are meant to be. Because again, we've got an irritating sort of noise. We'll call that the irritating sort of noise. And then you should be able to move away from it it does not take that many filtering stages to feel like you're a good distance away from it, and the really large amount of filtering, who's to say that you're going to have that many sound creating objects active in a scene? So you're like a good ways away from the thing. Here's close. Here's a good way away. Since it is a filter, since it's an averaging filter, its behavior is actually pretty good as far as being a natural roll-off. This particular technique is... oh no, it freaked out. This particular technique is good at natural roll-offs. This... okay, that was noisy. That was at full volume too. So maybe I shouldn't have RT60 settable to full infinite sustain. That might be a little too dangerous. Let's step away from this for a moment and try to do something more safe. Such as, okay, speaking of more safe, guess what? Let's not add +1 to this. Turned out that was a dumb idea. The way I've got it set it now, it cannot do the infinite sustain thing no matter what you do to it. Don't worry, it's just, I don't think I blew anything up. My apologies if I upset stream by the bursts of noise. You take your chances. You take your chances. Anywho, here's our reverb. Here is our concept for new distance algorithm that could work both for this, but it could be just as much part of the inherent Godot calculations for this stuff, especially if I can make it work cleanly enough. I feel like going... so... one fewer operation. Another fewer operation. And then we probably, this might be just fine as two discrete operations. I don't have to build it into a compound statement. Seems to me like I might as well not put it into a compound statement. It's fine the way it is. But now, we are not averaging off of just only previous sample. Now we're doing a kind of IIR filter built into it. Let's see what happens now. So since this is a low-pass filter, I don't believe there is any way that it can blow up or go crazy. But it can probably go way darker easier. That might be an entirely desirable thing. But I feel that's what's going to happen. It's going to go darker easier. I need to ask the Godot people whether they expect to let people set different sample rates or whether everything is going to run at a sort of default Godot sample rate. I don't know what they've got going on for that stuff. I'm not sure at all what they have going on. Okay, so this isn't doing crazy things. This is just making a loud noise. In fact, We've just set it to where this is now the max. And it will never feed back and go out of control, quite. I'm hearing a clicking as the distance decreases. It gets louder, and it sure as heck is rolling off more. This is like a pretty convincing mile off kind of thing. So I feel like 64 is not necessarily the largest. Here's a very cool thing, which may or may not be useful. I've made it filter more by taking instructions out. That means if we're going for a particular degree of darkness this way, I've just made it way more efficient by not only not running as many operations inside the loop, but the loop does more now. I'm kind of digging this texture. That sounds really the heck far off. So if you're moving around in world space, you would probably move one step at a time rather than sudden jumps. Granted, it can do sudden jumps very well. What it doesn't seem to like is click and drag, and that seems to be causing zippery noise kind of things. But when we move smoothly, all the way up to the brightest, so I wonder whether there's something I can do about that. Liking this so far. If I was able to render one extra stage and then crossfade into that, it would quit that stepping behavior. The whole thing is very efficient. It's probably worth a try. So effectively, rather than trying to make it do steps that are smoother, like this is closest, then you can do this, and you can do this, it rapidly starts falling off, like 2 stages and we're already seemingly quite far away. If there's a linear motion between those phases and it's crossfading between one and the other, then what you get is still individual steps of filtration, but without a sharp snap between. Okay, so rarely in it, check this out. So we can do this. We can cut off the high frequencies, but we're too far away to be able to hear a distanced. And this is the high pass, which isn't necessarily going to do what you're looking for either, but it will presumably cut lows a little bit. The purpose of it is if you were inside a space that is losing low bass through the walls. So wall density, this is meant to be we are inside a cave of some kind, versus we are inside some big place, it's not a cave, therefore low frequencies get away. However, with regard to actually distance alone doing that, check out thunder sometime. Low frequencies are all you're left with at extreme distance. And then there's also a pressure discontinuity, which I've done a bunch of work on, like with the plug-in discontinuity. And that pressure discontinuity changes the shape of the wave, causing things like rocket launches to produce a characteristic crackling sound. And that's all very cool and interesting. But the bottom line is, some of the acoustic phenomena we experience is because you lose highs and then mids and then low mids and all that kind of stuff, but the only thing you don't lose is the extreme lows. But the part where it matters is more like this, where we're doing a sound that is acting like there is a large acoustic space, like it's not the perfect one for this, but supposing this is a giant warehouse. Well, I'll continue to demonstrate a little bit. So if you're inside a giant warehouse, this accurate to thunder behavior isn't necessarily what you want. Because over miles and miles of open space, yes, what you don't lose is the extreme lows. If you're in a room, the room is echoing high frequencies, mid frequencies, stuff like so now we're in like an empty place. And if we have a little of the reflection toning itself down, it acts a little more like there are walls that aren't just glass. But then if we are cutting down the low frequencies, the sound is going to change from this sort of weird thundery thing that sounds cave-like to something that's more like a structure. Because in a structure, low frequencies leak out the walls. Low frequencies leak out of physical objects where their rigidity is not enough to contain the super sublows. So we use this type of high passing to sound more like an acoustic space. Maximum bassiness. We can pull it back a little bit, or we can pull it back a lot. And that can produce a more accurate sound for an acoustic space that is a physical structure that doesn't have infinite rigidity walls. And then you might have the RT60 not being quite that big. Or you might have all-pass filters in there, giving it a different style. I still think the all-pass filters make it sound more like it's a complicated structure. I think somebody earlier on Yeah, it's going to be about an hour and 10 minutes, I would say. The somebody earlier was saying, I think comb filters sound more like a complicated space. I'm not sure I agree. To me, this feels like a complicated space with lots of detail, lots of geometry. This feels more like an emptier space. Even though it's dependent to some extent on the fact that the underlying algorithm is going to have a large amount of say in that. But given that those are simply echoes at a given set of echoiness, let's bump up the sustain a little more. So, comb filter still sounds to me like the emptiest of spaces, like a square box. This really does sound more to me like a more complicated space. People call the comb filter sound metallic. I've got a lot of people who respond to it like, I hate that because I want stuff to sound smoother, like a reverb. And that's usually done with all passes. So these are the all passes. If you go halfways, you get kind of a combination. No, not caps 2. So what I could do to make that work, given that we are tinkering with all of these things, is eight minus this, and then we're going to call it like geometry or complex. Complex works. So complex means increase it if the shapes that are around you are complicated. Lower it if the shapes around you are very simple empty boxes like a warehouse or whatever. And really what it's doing is it's bringing in all passes. But I feel that has a similar effect. That means we get to change the name. Ooh, that's a reserved word. But this isn't. Calling it wall dense. I could try calling it solidity. It could be like, okay, how solid is the structure that you're in? Because otherwise it's like, wall dance? Why do I want to dance with a wall? That would be like dancing about architecture. And there's got to be a better way of explaining it. So also, how many letters would it be? I could throw in WL to imply that it's part of walls. I mean, this is all because I'm restricting myself to 7 letters, so I don't really need to go this hard. So solid wall and reflect wall. There's names people use for these things like damping and such. Not sure if I'm that interested. So distance. Well, we'll go to that maximum 64. Technically it's 66 here. But here's where we can fool with it a little bit. Param E, distance. Let's get a little playful with this. Because what I'm trying to do is make it so that I can manipulate it around. It'll give me what I need, but then I can make it slowly shift from one thing to the next. I feel like this is going to involve me doing some more temporary variables. But what I can do first is test it to make sure it still does the thing I thought. So let's see. Distance output low pass. Generic. That one goes from 0 to 1, except wait, there's more. I know I'm trying to get to a maximum of 64, so we can simply do a little power function with this and have it go from 0 to 8. If I multiply that by itself, I get a continuous smooth transition from 0 to 64. And that'll be convenient. And the default is 0, so that seems legit. And int distance equals, first of all, int pow param e times 2, or to the second power, rather. So I should be able to run this and it will do something for me. Although it won't have solved the problem I ran into, it will be rearranging it in such a way that those snaps between positions will be in different places now. Quite different places, in fact. So, also still have not, oh, and it's 4. Tell you what, I'm going to make this set itself up and go booming and making noise, and I'm going to scoot away and do my thawing my cheese out for my tacos. Hopefully I can still get beef for making tacos with in future. We'll find out. Anywho. Here's our... This now rolls the same as it did before. Note that the density of the nodes right at the end is extremely finely grained. So we can go to this maximum distance, but then much more of this is a reasonable distance rather than a unreasonable distance. And we've still got the sudden snap from one brightness level to the next. And we're still popping as we zoom upwards in frequency. And this is what I'm wondering. Some of that's probably simply zipper noise. But you can clearly hear in the highs when you zoom in closer, there's distinct steps in the highs. Cares much less down here. Fixed low-pass filter positions for extra lows. Well, I just said I was going to set this going and then go off and thaw out some of my taco cheese. So I'm going to be good to my word, and I'll be right back doing a little self-care. I get to have dinner today. Kind of lucky that way. Alrighty. And I don't get to run it on dry, sadly. Maybe I should set it up so you can. I can get to run it on a kind of dry. Sort of a sparky, echoey, flashy thing going on here. So while I was fooling around with my tacos and stuff, I had an idea, which is I can make a special case for there are so few instances of the filter that I need to crossfade between them. I think that's probably the best idea. So what's that going to mean? First of all, we're still dealing with distance producing the same end results. And yeah, what I just did say that I could also include this. So let's put the distance on the bottom of literally everything. In fact, that will entail me shifting around the stuff a bit. So look at me making lots of extra work for myself. Do you see what I just did? We just had to change all of these things, I guess. Oh well. So then and then these guys are both floats, and pre-delay is the one that was an int. Which I think I had set to 10 or something. Anyways, reflective wall, pre-delay, dry, wet, and distance. Honestly, I'm not sure there's a special reason for me to have to do pre-delay as a int. It's not part of the ones that we're going to be giving me ints to build into settings. This is more along the lines of let's just make it be something. So funny how I've been using floats, but I always initiate them with doubles. There we are. So there's even more changes that have to be made, but it'll be a little bit straightforward anyhow. So having done this, all these beginning ones are ints, 4 settings that dictate the behavior of the reverb, and then 3 settings that don't. I'm going to need to look at that again. Then 4 settings that dictate the behavior of the reverb and 3 settings that don't. Distance output goes from 0 to 8. This was, I have to go back here. Okay. Distance output goes from 0 to 8. Pre-delay goes to 64, and that in turn is multiplied, and then dry wet goes from 0 to 1. Well, they're all generic. I'll apply that elsewhere. Everything other than distance. Distance is multiplied by itself, so 8 times 8 becomes 64, which is its largest value, and there we are. And the rest of it is fine, I guess. No, it's not, because we haven't got this set up. Got to do... hang on. Whoa. This moves down to where I use it, and this doesn't get to go up to 8, does it? No, no, no. It also isn't pre-delay, is it? No, no, no. That's pre-delay. That's dry wet. And that's distance. Okay. A little more fussing with it and we should be good. Then I'll probably need to run it again, see if it's working. But we'll also get to hear what dry sounds at distance now. That'll be nice. So distance. Moves down here. Pre-delay is now E. But no. It's going to require some fuss. That'll give us up to our 4096 maximum delay. And we will explicitly cast it to int. Then wet is now F, and distance is now G. Honestly, I don't see any special reason why this should be going to 8 as part of this calculation when it can just go to 1, which is the same thing that we do in VSTs, meaning we don't have to fuss over this anymore. And then I can follow the same pattern. And we're going to continue doing that. And that should work. I think it'll work. I guess we'll find out whether it'll work. If I wanted to be extra fussy, I could put the pre-delay right up top. But practically, I like the idea of having the reverb-related controls being the 4 ones up top. Below that is how we're using it in the plugin, basically. Although distance is kind of like reverb related, but in this instance I think we're good enough. Okay, so here's what we got so far. We're not quite done, but better than nothing. And this part of it does work. It's even handling the enlarging distance without causing unpleasant noises. And rightly so. Never did do that undersampling thing. I wanted to do a very primitive undersampling just for the plugins so that if you did use it on higher sample rate stuff, it would at least give you the correct result. I was thinking about doing a linear interpolation like I do in the more recent dereses, because I don't want to go full Bezier on this. This is a game engine thing. I could also do a nearest neighbor, which basically is the same as sample and hold. It's not doing any interpolation. It's just... Alrighty, new appearance. Everything's set to 0. But if everything is not, we still get to apply distance. Given that there's no volume attenuation, which would be a factor, this is, I think, pretty good. Let's see what we get out of, like, alien kittens. So that definitely sounds a lot more distant. And we don't even have that much reverb in here. Nearly all dry. So if we were to be backing away from this Godot object and the reverb that's being excited by it, it would sound kind of like this. And then if we were approaching it, what I'm probably going to hear here, if I move it smoothly enough, is a decent sounding approach effect up to the point when it starts abruptly transitioning from one averaging to the next. And I feel like those will be unpleasantly sudden transitions. And so that's the thing I'd like to do with the final half hour, is solve that. And I may very well be able to do so, because the important thing is being able to come up with the special cases where it can efficiently run all of this kind of stuff. Still good? Still good? Okay, That wasn't as obvious as I thought it might be, but I bet I can come up with something that is. We'll do a sort of sustainy thing. With this, I should be able to clearly hear distinctions as we move about. So if we're at a big distance, there's sustaining high frequencies in there. That's a cool noise. And past this point, it's like a nice smooth transition. The fact that it's a repeating sound is having an effect on it. There we go. A bright, sustaining noise. We can't really hear the transition points this far away, nor can you really hear them on bassy stuff, which is why I'm using a bright sound for it. There's a sudden transition. And there's the final transition to being right up front. So the way it snaps to the higher frequency regions sounds like a switch being thrown. And when you've already got some filtering going on, it's much less obvious. So, all this happens when we are having a very low distance number. Yep. Let's quickly indent that a little more nicely. There we go. So we'll run a special case. If distance is small enough that we care, and we know we're not going to be doing lots of instances of it, we'll do a sort of run an extra instance and crossfade them. And that will be, for starters, a little bit like just having the same thing there again. Because it holds, like what I'm doing here still holds. That we're going to want to do the same smoothing behavior and so on. There is just one change, which is distance now doesn't get to be an int. Also, I am bored with this 7-letter thing. Okay, so now we've got a float that goes from 0 to 64, and we've got an int that is that minus whatever the fraction is going to be. Pretty sure that's going to be functional. God, excuse me. Water got stuck in my throat. How's that happen? This, of course, means I can just do that. And now we've got it working exactly the same as it was before. Brief distance is a int, unless I'm very much mistaken. Yeah, it totally is. That's what it's supposed to be. So we don't need to care about brief distance. That's just calculating out whether stuff is being changed or altered. But here's where it gets a little more complicated. There. Now distance is a fractional number like a dry wet that we can use to crossfade between levels of the algorithm. And it's only going to apply at low levels of calculation. So this one, we start making an extra equation, by which I mean variable, not equation. This is the loop by which we do our thing. This is the loop by which we either apply filtering or don't. Distance steps is going to be 0 if it is 0. Firm grasp of the obvious today. Oh, you're quite welcome, Mr. Blue. It's going to be 1 snapping to 0 at the one that I'm most concerned about, but every step of the way, if it is a particular value, and we can actually soften this up a little bit, like supposing if it was less than 6, we start doing this stuff with it. What we're looking for is how close is x to distance steps. That's the point where we do a crossfade. So we're iterating through this. And if x is less than brief distance, I think I can skip that, or at least not think too much about it. And I'll tell you why. Because brief distance is what stops it. Like, brief distance is going to end up being distance steps pretty much on every occasion, unless we are actively transitioning from one setting to the next. So mostly we don't actually have to care about that. It's going to act the same as if x is less than distance steps, which is what this is, so we should never actually see this. It's the same as if this wasn't there at all, with very few exceptions. That means this is kind of the same as this. Generally, with very few exceptions, it is going to be doing this thing. And then we're iteratively doing this thing in this little stack of nested ifs, which are there to check whether or not we've suddenly changed stuff around and need to blank things out or whatever. So here's where we start defining a variable. Before doing anything to input sample, we're going to store up the previous one that we had. If we're doing one stage of filtering, then this is literally dry sample. If we're doing multiple stages of filtering, it is whatever the most recent version was. And then we do this and we get the filtered version. But what do we do if we want to crossfade between the previous version? Here's where the actual variable distance comes in. But that's an assignment, and that's also not correct. However, x is incrementing. X is working its way up to 1 less than distance steps, because every time that evaluates to true, we go again, and then we increment x. When x equals distance steps, we're not running this anymore. That's why if it's 0, we get to have things be completely dry. Just everything falls straight through and nothing happens. So this means either we are evaluating against distance steps -1 or x plus 1. We could make it distance steps -1. That means we are on the last or possibly the only evaluation step, and we need to split the difference between the filtered amount that we've got and the dry amount that was previously there. So that's logical and works. Then for now, I'm going to put the brackets in so I have more room to work with. And in theory, that should do it. So how does this actually work? Bearing in mind that I don't actually need those brackets there, but this should be the thing that makes it function properly. I'm going to talk my way through it, and then we're going to try it. So each step of the way we've declared hang on. What do we call this? Earlier stage, because this is a succession of filtering stages. So at each step of the way, we get to refer to earlier stage, which is whatever input sample was doing before we filtered it. Then, if x equals distance steps -1, let's assume we're in the very first step where nothing happens if it's 0. If it's 1, we start doing this, but it's only just kicked in. So what we want is to end up with earlier stage anyway. So if distance steps is 1, but let's say that distance is 1.000001. We've just barely touched the first filtering stage. So we want to mostly be leaning on earlier stage. Well, distance being 1.00001 makes distance steps be 1, and then we subtract it from, so then we get distance being 0.00001. We have got a tiny amount of distance for the now filtered version. So we're going to want to do this. I had it backwards. And also I ain't using floating point notation properly. No sense in having it converted over from double to float. So every step of the way we are declaring earlier stage, but we're checking to see if it's the final one we got to. If it is, we are reverting to earlier stage but crossfading it with the newly filtered one, depending upon how far we are into that stage. And then this is about just being able to run it more efficiently at the point that we probably don't care because it's not obvious anymore. Then it will just snap to newer steps. We'll cut it from 4. We'll cut it 2/4 rather. We're continuing to do this. I'm going to see what we get, and let's see whether this works first time. If so, I have a little bit over 15 minutes to do that very primitive sample rate adjustment that I wanted. Can but try. Hi-hat noise. Actually, here's a couple of noises. We'll do those. Or we'll do these. Let's fill the space with some sound. That's the sound. Now, what's our transitions sounding like? That ain't working. What did I get wrong? Well, I clearly got something wrong. So what happened? If distance steps is less than 5, we start counting through our stuff. X less than prev distance should be, well, maybe that's the problem. What if that's the concern? Well, shucks, let's see what happens. Maybe what I need to do is incorporate earlier stage into this. Seems a bit weird, though. Wait, no, I can't, because it doesn't exist in that. Well, we're trying to, maybe it's because if x equals distance steps minus 1. So this shouldn't be possible. I should have just made that unable to function, which was exactly what it was doing before, so I feel like I've missed a trick somewhere. Back into this. That's not the right kind of sound, though. I need a hi-hat. There's a hi-hat. Yeah, that is an abrupt transition around about there. Well, now, what if I tried to do this at every stage? Never mind whether this makes sense, would it work? Now we're automatically doing it no matter what. Also, I do believe I am adjusting distance the way I thought. Yep. Casting it to int, and then minus equals. We'll cast that to float, and then we'll make sure everything works. So we can still defeat this by making it apply only on very low order versions, but now we're attempting to make it go for every single instance. Back into the breach, let's see what we got. If that works, then I don't need the if statement because it's just true now. Okay, now we got a sudden transition. And also ain't nothing happening after a certain point, so that's unexpected. Dare I say undesirable. Can I get it to work in any way, shape, or form? Can we fade into the first one? How about? What if I only fade into the very first one? In which case, no loop is needed. That'd be a little awkward. I don't love that, but maybe it would work. Dinner time is kind of looming. I hope I'm able to, clearly I'm not going to be able to do the sample rate thing. I'll do that on my own time. If I'm lucky, I can make this work before my time is up. It'd be nice. So this didn't actually do me any good. What if we get a little bit more experimental? So if distance steps is less than 5, we don't attempt to do this brief distance stuff. Nor do we clear out previous versions. Instead, we'll try to run this just as it is. And we'll see whether anything else happens. I do remember that as we were getting more filtered, that's when stuff started getting a little twisted. So maybe this is... Let's lower this even further. Because this is the one where we know it works. I just want more smooth crossfading at the very top. And we can define our layer stage. Here's, oh, and we don't need to do this because it's already always true. So much for that. So much for that. Let's reflow this. That's not how we do it. And then we're going to step through that there. If true means we're already doing it, so we get to skip that too. This is actually kind of nicely and conveniently tidy. Like if the whole thing fails, I don't need to do any of that stuff. So it's like, okay, this might be just the very first one, and then everything else works this other way. Stepping through here. Earlier stage defined here inside the for loop. Doing the prev sample. Scaling it back, prev sample equals input sample. We're going to walk through every single one. And after having assigned prev sample, now we start crossfading between earlier stage, which currently was not doing that. We might very well need a if statement here. But who knows, perhaps not. And let's see if we can get this into a zone where it's doing the crossfade in a way that I can appreciate. That would be cool if I could. I'd like that. Don't know whether it's really in the cards. Hats. Highs. Abrupt transition. Rest seems basically okay. That should be able to do a dry wet. Alrighty, what happens if we kick it in way later? This is going to interfere with everything real hard, but we'll see what it does. Does it ever do anything, or does it fail with everything? It's acting kind of like, okay, it's starting with earlier stage equals the very first input sample. If every stage automatically goes to 100% earlier stage, always, then it always stays full bright. So if that's true, then on the one hand, I know that's what's happening. And that'll mean that if it does this, then it's going to stay fully bright until it suddenly snaps to very, very dark. Yeah, that's what we're doing. We're hanging on to earlier stage. As if distance wasn't being a factor. And I'm still not understanding why I don't get to scale distance up from 0 to 1. This really should be able to do a crossfade. I am disappointed at that behavior. Float times 8 to the power of 2 does give me a large number. Distance steps becomes that large number. Is it becoming a negative number or something? So that should be rounding down. Really should. Maybe instead of doing that, what I got to do is go about doing this a little bit more manually. Oh, I'm running out of time. In theory, that should be a thing. We can but try. We're no longer even referring to the int anymore. It's giving us good enough behavior. My question becomes, can I get any of this to work doing anything? I want to get this done before I go and have tacos. I'm going to be extremely naughty and continue hacking instead of eating. You know, that's just how I roll, right? I feel like I'm moving fast enough that it's not going to delay me too much. No change. So distance, distance of 0.5 minus floor 0.5, that's 0 again. Distance of 1.5 minus floor 1.5 should be 0.5 again. I should be getting a varying thing going between 0 and 1. There's a little game that I can play, however, which will show me what's happening. There. So whatever it thinks it's doing, I should be able to get a volume ramp out of it now. Technically, I could do that on the end of everything, and it wouldn't matter. Let's find out what it's doing. Actually, you know what? I'm going to literally do that thing. We're going to put it on the end of everything, because it is a variable that's available globally, and it should be doing a sort of little sawtooth wave thing where the amplitude of the final output will be going 0 to 1, 0 to 1, 0 to 1 over and over again. Unless something horrible and weird is wrong, in which case that'll tell me, it'll speak volumes. But this is going to show me what distance is. There's a hat. It gives me high frequency reverbs that make it easier for me to hear what's going on. Distance is always 0. What business does it have being that? I ask you. At no point is it anything other than 0. Well, that explains a lot. Why is it happening, though? We're not incrementing it or doing anything with it here. Oh, pfft. I'm a silly man. See this? That stopped it being able to do anything. Now let's give it a try. In fact, we can even return to the original formulation. See, we're casting it to int twice. No good reason for that. Return to the original formulation. We've still got it ramping, but this should at least make a noise if it's doing what it's supposed to. And then we can explore some of the other stuff that I had. Yep. So hep. That's what distance is supposed to be doing, and what I thought it was doing the whole time. At this lowest setting, it is at 0. Here's where it transitions. When it switches to the next level of filtering, it snaps back to 0 again. So that is actually also telling me that distance is not at 1 as it ramps up. So this is technically correct. This is also correct. We're doing it at a stage of 8. This is where I would be putting in, like, only do it at the final stage. The code for doing that previously was, because now we know that wasn't the problem. And that's what I had initially, in the belief that that was going to work and apply it at only the final stage of filtering, thus crossfading only where it was supposed to. In theory, that will do the job at only 5 minutes over dinner time. And we'll see whether that is in fact true. If so, I'm going to shout hooray and end the stream. And I'll be doing the other thing I was talking about at some other time. But we'll see whether that was the silly blunder that invalidated everything else being actually fine. Then I get to decide how many of these need to run the slightly less efficient one, and at what point can I switch over to this, which is more efficient. Plus also, I seem to have deleted this bit. Because we're not doing brief distance here. Let's remember to do a build. I probably already had. And then let's go and find a hi-hat noise, which I can recognize by being bigger on one side than the other. And let's see what this does now. There are some high frequency sounds. Okay. We got there. There's a bit of a dead zone in there, but that's probably not wrong. We're probably fine with that. There's the highs we're trying to interact with. And then the simpler form without the little crossfade for 64 layers of it. Because by 64 layers, we can't tell. And dry. Cobains. Got there. Alrighty. So that was, what the hell was that? That was work on the ultralight plugin. Ultralight plugin being the reverb that I'm trying to develop for the purposes of Godot. You didn't get to hear any of the good reverbs, but then neither have I. I've only heard the one that I just tried, which ended up being a giant-sized space that sounds kind of awful. I'm sure I can do better than that. In fact, I probably already have many times over. That's just a 3,000-seater arena, which you can't really do very well with a 4x4 matrix. That's why I use my 6x6 matrices for things. Whoa, okay. Well, that was quite something. Happy to say I got through to the end of it. I'm sorry to say that it was because I was casting a thing to int where it wasn't supposed to be cast, but that was a simple bug. So often that's how that stuff works out. The concept I had in mind for getting it to work was basically correct straight out of the gate. It's just that I had a control issue with the variable that needed to be a floating point number, and I had made the foolish mistake of casting it to an int and then doing everything else with it that would have worked if it hadn't already been rounded to just an integer at all times. What are you going to do? Well, I can tell you what I did, which was I needed to not go and have dinner until I had it sorted out. But, it only took me an extra 15 minutes. I feel like that's a reasonable trade-off. And sometimes that's how it rolls. Like, sometimes there's an answer to the thing. And you just look over your previous stuff until you see the int there and go, why is that there? Oh, no. And then you fix it and it's fine. So I'll get back to this probably next week unless I'm working on something else at the time. I'm going to head over to have my tacos now and probably not work on it any further. I think it's at a stable place at this point. I'm looking forward to telling the Godot people that I probably have a nice and efficient distance filter for their engine. And I'm probably going to call it Godistance, I think. I'm going to put this out as a standalone plugin, which doesn't mean it makes it better than the existing distance, which is complicated by now, and there's a lot going on. But this is an insanely lightweight version of it that's just stacking averaging filters that are combination averaging and IIR. It is what it is, and I'll talk to you later. I haven't decided what I'm going to post for this weekend. I'm going to post some kind of plugin this weekend and do some of my Forbidden and Patron record playing videos. and I'll talk to you later. Bye-bye.